Good evening to all. I am E. Manohar from CSMB section SRIT. I would like to talk about Ohm's law and its applications. Introduction to Ohm's law. Ohm's law describes the relationship between voltage, current, and resistance in a electric circuit. It is fundamental for understanding how electrical devices operate. States of Ohm's law. It states that at constant temperature, the current flowing through a conductor is directly proportional to the voltage applied across it. Simple explanation: if voltage increases, current also increases. If resistance increases, current decreases. Basic concepts of Ohm's laws: voltage, current, and resistance. Voltage is the potential difference between 2 points. It is the driving force that pushes electric current. Unit volts V. Example: a battery provides voltage. And second one is current. Current is the flow of electric charge, electrons. It shows the how much charge flows per second. Unit ampere. Example: current flows through a wire when connected to a battery. Resistance is the opposition to the flow of current. Higher resistance, less current. Unit ohms. A resistor limits current in a circuit. The mathematical formula for Ohm's law. Ohm's law is expressed as V is equals to IR, where V is equals to voltage in volts, V current, I is equals to current in amperes, A resistance, R is equals to resistance in ohms, ohm. This formula allows calculation of any one variable if the other two are known. It provides a simple way to analyze and design electrical circuits. Applying Ohm's law in a circuit analysis. To analyze a circuit, identify voltage sources, resistors, and current paths. Use Ohm's law to determine unknown voltage, current, and resistance. It helps troubleshoot problems and optimize circuit performance. This is the example for Ohm's law and calculation. Suppose a resistance of Ohm's law 100 ohms has a current of 0.5 amperes flowing through it. Using Ohm's law to calculate the resistance, V is equals to 0.5 into 100 is equals to 50 volts. This calculation helps in designing circuits with appropriate voltage levels. Power dissipated in a resistor can be calculated by using P is equals to V into I. Alternately, P is equals to I squared into R, or P is equals to V squared by R can be used depending on known values. Understanding power helps prevent components from overheating and ensure safety. Practical applications of Ohm's law: designing electrical circuits. Electrical applications: heater, sirens, like it is used in a designing electrical and electronic device circuits. Engineers rely on it to select appropriate resistance values. It also aids in diagnosing faults in electrical systems. Ohm's law applies only to ohmic linear materials that have a constant resistance. Non-linear devices like diodes and transistors do not follow Ohm's law directly. Temperature changes can also affect resistance, impacting the law's accuracy. Temperature must remain constant, wide only for ohmic conductors, not applicable to semiconductors, not valid for high voltage or current, not applicable to ionic solutions and gases, does not apply to unilateral devices. Real world examples: electric bulb, diode, mobile phone, electrolytic solution, LED light. These are the real world examples. Adjusting resistance in a circuit to control current flow in household wiring, designing and developing circuit protection devices like fuses and circuit breakers. Conclusion and summary. Ohm's law provides a fundamental relationship for understanding electrical circuits. It is essential for circuit designing, analysis, and troubleshooting. Mastery of Ohm's law is a circular of for anyone working with electrical and electronic systems.